Good morning, students. Myself, RAGHAVARAJU. This video lecture enhance your knowledge on unit number 2, antenna wave propagation as per JNTUK. So, as an application, continuation of this half flow dipole, it is called RAGHAVARAJU antenna. So, the extension of this half flow dipole shows its effect on the basic RAGHAVARAJU antenna. This basic RAGHAVARAJU antenna consists of driven element. So in RAGHAVARAJU, we have one driven element, one reflector, and one more reflectors. So basically, it is an array. The array has one driven element, more parasitic elements in its configuration. The driven element is a resonant half-wave dipole that should be made of metallic rod. The parasitic elements, which are continuously arranged parallel to the driven element and at the same line of sight. So all the elements are placed parallel to each other. So therefore they will form the particular structure like this. So the parasitic elements receive excitation. The parasitic elements receive excitation through the induced EMF. So that current flows in the driven element. The phase and amplitude of the currents through the parasitic elements mainly depends upon length of the elements, spacing between the elements. So to vary the reactance of any element, the dimensions of particular elements are adjusted. So that's why the radiation properly achieved through this arrangement. Generally, the spacing between the driven and parasitic elements are measurable in terms of lambda values. So the spacing element between driven and parasitics are 0.1 lambda to 0.15 lambda. So this RAGHAVARAJU antenna, the RAGHAVARAJU antenna has reflector, director, like the same basic antenna. The elements at the backside of the particular driven element is the reflector. So this is the element. This is the element. So the element at the backside of the driven element is the reflector. Therefore, reflector, driven, and director are particularly used in the algorithm. The elements which are used at the backside of the particular driven element. So therefore, that element backside of the driven element has that reflector. So this is the reflector. So this is the reflector. And this is the driven element. This is the reflector, driven element, and director. So the reflector has length 0.55 lambda. The driven, which is feed point, that is 0.1 lambda. The separation between driven and director 0.1 lambda. So this is the reflector. This is the reflector. So the reflector has length 0.55. So this is the director or simply reflector. So this is the reflector. And this is the corresponding this is the corresponding driven. So that is the feed point. So they, at this feed point, where feed point, this feed point. So driven, so 0.5 lambda, and that is 0.45 lambda. All are separable. All are separable by 0.1 lambda, 0.1 lambda, and 0.1 lambda. And when this half-wave dipole is situated, and this half-wave dipole situated, so their main beam, the major beam is positioned like this. This is the major beam position, desired beam radiation. So this desired beam radiation aligns on this driven. So therefore, the maximum of major beam, the maximum of main beam axis is positioned along the main or major loop. And this is called minor lobes. These are called minor lobes. So these are side lobes or back lobes. So these side lobes and the back lobes are known as the particular reflector. This is the main and so main beam is aligned along the major axis. So minor lobes are aligned on major lobe, and this is the main lobe. So it is of larger length, so compared with the remaining elements. So the elements in front of the driven element and director, which is the lowest length in all three elements. So these are the lengths of different elements can be obtained by using this formula. So reflector length that equal to your 152 by f, like this. And the director length equal to your 132 by this director length equal to your 132 by meter. So let us consider the major action of this half-wave dipole antenna. So the parasitic elements. So the parasitic elements is used either to direct or reflect the radiating energy, forming the compact directional antenna. If the parasitic elements are greater than this length lambda by 2, the inductive in nature. If the parasitic elements are greater than length lambda by 2, then it is inductive in nature. So hence the phase, hence the phase of the current in such element. Hence the phase of the current in such element that is in a reflector lacks the induced voltage. So while if the parasitic element is less than the resonant length lambda by 2, hence the phase of the current is such that the reflector lacks the induced voltage, while if the parasitic element is less than the resonant length by 2, then it is while if the parasitic element is less than the length resonant length lambda by 2, so then it is capacitive in nature. So hence the current in the director leads the induced voltage. So the director adds the fields of the driven element. The director adds the fields of the driven element in the direction way from the particular driven element. So if an array more than one director So let us consider the action of this Uda. So the parasitic elements, while if the parasitic elements are less than resonant length So then it is a capacitive in nature. So hence the current in the director leads to induced voltage. So the directors adds the field of driven element in the direction away from the driven element. So if an array more than one directors are used, then in such case the first director exits the next and so on. So mm, exactly the opposite to this properly spaced reflector adds the field's driven element direction towards the particular length. So exactly the opposite to this properly placed reflectors adds the fields of the driven element in the direction towards the driven element from the reflector. So to increase the gain of particular Agioda antenna. So the number of directors increased in the beam direction. So to get good excitations, the elements are closely spaced. The elements are closely spaced if the distance between the driven element and the directors are greater than correcting phase of the particular parasitic element and more than capacitive reactance to achieve this proper tapering. So the radiation is in the particular direction. So this is the very important condition. This is very important condition you have to understand in your knowledge. So the radiation is in the direction front to rear. So part of the radiation induces currents in the parasitic elements, which actually re-radiate almost all radiations. So with the proper length of the parasitic elements, and the spacing between the elements, the background radiation is cancelled and the radiating energy is added in front. So when the spacing between the driven element and the spacing between the driven element and the parasitic elements are reduced, so the driven element gets loaded, which reduces the input impedance at the terminal of the particular driven element. So to overcome this driven element used as a folded dipole, which maintains the impedance at the proper input terminals. So this is the radiation properly achievable to overcome with this driven element used in the folded dipole. So which maintains the impedance at which maintains the properly to overcome this the driven element is used in the folder dipole, which maintains the impedance at the input terminals. So this is very important figure. So This is the very important half-wave dipole. So this is the reflector and this is the dipole. This is the director. So director, dipole, and so this reflector, this reflector focuses. This reflector reflects the signal. So it is very understand. Reflectors reflects the signal coming from front side and totally attenuates the transmission signal from back side. And this is the back lobe. This is the back lobe, which is the minimum directivity from back side. This is the back lobe, which is small directivity back lobe. So this is the reflector length. This is the reflector length, which is having 0.55 lambda. So 0.55 lambda. So reflect the signal coming from front side and totally attenuates the transmission signal from back side. So this is the dipole, reflector, and director. So these are called side lobes. These two side lobes, very small directivity, and this is the director. So it retransmits the signal collected from front side towards dipole. Retransmit the signal collected from the front side towards the dipole. So it attenuates the signal coming from the back side and side by side. This is the main lobe, which is having maximum in the direction of reception. This is the maximum direction. So finally, this total radiated signal. So this is the total radiated signal, which is having the particular beam width. So this reflector, which shows, so suppose this is the length, this is the length of the particular reflector, this is the length of particular dipole, this is the length of particular director. So reflector reflects the signal coming from front side and totally attenuates the transmission signals from the back side. Similarly, back lobe. This back lobe minimum directivity from that back side and totally it will attenuate the signal from the particular direction. So this reflector. So this is the reflector. So this reflector reflects the signal coming from front side and it totally attenuates the transmission signals from back side, and this is the dipole. And this is the director retransmits the signal from retransmits the signal from the front side towards the dipole. It will coming back, retransmitting the signal collected from the front side towards dipole. So it attenuates the signal coming from the side and the back side. This is the main lobe or major lobe of radiation pattern, maximum in the direction of radiation, and this is the back lobe. So these are the various dimensions which are pointed. These are the various dimensions, that is direct length and dipole length. These are the various dimensions that are pointed. General characteristics. These are the main half-wave dipole general characteristics. It is having 3 elements, including one reflector, one driven element, and one director, and commonly called as the main beam antenna, the RAGHAVARAJU antenna. The RAGHAVARAJU antenna with 3 elements, including one reflector, one driven element, and one director, commonly called beam antenna. So generally, it is generally a fixed frequency operated. So it is generally a fixed frequency operated unit. It is generally a fixed frequency operated unit. So this antenna is frequency sensitive. This antenna is frequency sensitive. The beam width. It is generally the beam width of particular antenna. So this antenna is very sensitive to frequency, and the beam width of bandwidth of 3% can be easily obtained. Such bandwidth is sufficient to television reception. So the bandwidth of 2% to 3% can be easily achieved with this spacing. Between 0.1 lambda to 0.5 lambda. So the gain of this RAGHAVARAJU, the gain of particular RAGHAVARAJU is about 7 to 8 dB, and it is the ratio, and that is 20 dB. So this antenna gives this is the very important calculations. This is the important calculations This is Aggie antenna calculations. The length of the dipole, the length of the dipole equals to the L equals to 150 so 150 by frequency. The length of the dipole is 150 by frequency 1 by 3 by f. And the dipole of length L equal to 143 by f. 143 divided by, and for reflector length L equals to 152 divided by f. 152 by f. From the first director D1, the first director D1 equals to the length Aguda. So the length Aguda, the first director equal to 137 by f meter. So that is the spacing. So spacing between reflector and driven, that equals to 0.25 lambda 40 divided by f omega h. The spacing between the director and the driven 40 by f. So, and the space. So this the salient features of the salient features of Aguda antenna basically consist of folded dipole driven element along the length, that is a reflector and more directors. So the directors and the reflectors are straight conductors, which are called parasitic elements. So the directors are placed in front of a driven element while the reflector is placed behind the driven element. So this length of the dipole is L by 2 while length of is greater than lambda. So the radiation pattern of Aguda antenna. The radiation pattern of Aguda antenna is almost identical. ఇక్కడ ఉంది So the folded radiation pattern of the are most unidirectional. So therefore the background which can reduce by placing the elements very close to each other. So the folded dipole elements resonant at a frequency of resonance. So but reflector resonance reflector resonance greater than this resonant frequency. So this current through this director is a leading current while through the reflector is a lagging current. The mutual impedance of antenna depends not only on them but also the spacing elements. So this is the basic advantages of anti-agula. It has excellent sensitivity. It is front to back ratio is excellent. It is transmitting. It is excellent sensitivity. So it has excellent sensitivity. It has excellent sensitivity. Its front to back ratio is excellent. So it is sensitivity. So sensitivity is one of the parameter. Sensitivity is one of the parameter. So it has excellent sensitivity. So sensitivity is one of the parameter to indicate the features of the the front to back ratio is excellent. So what is the front to back ratio? Front to back ratio is excellent. What is the meaning of front to back ratio is nothing but during the reception of this signal achieving the maximum main achieving the maximum main loop. So that is called front to back ratio. It is useful for transmitting the antenna at a high frequency for TV operations. So this five dipoles are very transmitting case. So it is um, antenna. So it is useful for at a high frequency for reception. So it has a single direction. That is very maximum advantage with Agivida. Unidirectional radiation pattern. So it is a single directional radiation pattern is very one of the popular advantage of Agivida. So due to use of this folded dipole, Agivida antenna is called broadband antenna. So it has excellent sensitivity. So So this is the disadvantage. Almost unidirectional radiation pattern. So due to the fold dipole, agioda is a broadband antenna. So already we know that very low profile agioda gain and bandwidth are limitations. The gain of the antenna increases with the reflected direction of the dipole of the particular antenna.